Welcome to our next unit. And so in this unit, I want to discuss the idea of a Go routine and then use that idea of a Go routine as a vehicle to discuss the idea of concurrency and the advantages of concurrency as well as the challenges. Okay, so let's say that I create two functions. Let's call one of them hello. And all it does is to print hello from hello. And then I have another function named world. And it simply displays the message world from world. Okay. So let's call these two functions. So I will say hello. And I will then say world. So right away before this program is run, we are quite certain of the results that will be displayed. We will see hello from hello, and we will see world from world. Great, that's very predictable. And so it turns out that our program is running in sequence. We will do line 16, and then we will do line 17. So this is a sequential program. Line 16 has to be executed before we get to line 17. And after line 17 is executed, then main exits. Now, keep in mind that main is our driver. So everything starts with main. So main contains all the other code. Now, main is a Go routine. Okay. So when the Go system starts up, it creates what we call a Go routine. Okay, an independent entity, and it lets it execute. And from within main, we can do other things such as call functions and so on. Now it turns out that we as programmers are able to tell Go that we want to create more independent entities just like main. Okay, so to do that, if we want to say, you know what, Go, I want hello and I want world to be independent. I want them to be executed on their own. Okay, so going forward, I don't want them to be linked to the main function. So what is the consequence of that? It means that I no longer know which one will execute, meaning I will no longer have 17 followed by 18 because Go will simply take them and say, okay, hello, you're on your own. World, you're on your own. And so to do that, I'm going to say Go in front. So in essence, what this does is to take the hello function as if it were something like main, meaning it executes on its own. And it does the same for world, does the same thing for world. So now we have lost this idea of determinism. We no longer know that we can no longer state that it's going to be hello from hello and world from world. We can't, because they are now independent functions, and we call them Go routines. So hello is a Go routine and world is a Go routine, which means when they will be executed is not known beforehand. Okay, so let's try running. Let's save it and let's run it again. Okay, so nothing gets executed, nothing is shown. And the reason why nothing is shown is because of the fact that we have told Go that these are now 3 independent things. So main, hello and world is no longer in that context of main. So it means that main, in a sense, is independent. So if we do call main, or when we call main, it just does line 17, it does line 18, and then it exits. It's no longer waiting for 17, and it's no longer waiting for line 18, okay? Because they are now independent. And so because main no longer waits, well, after it does 17 and 18, it exits. So there is a problem though, because main is our driver, meaning that everything starts with main. When main exits, unfortunately, the program as a whole exits. So even though we called hello and we called world, we never get to see what they do because the program has already ended, because main has already ended. So let's do a little stop gap approach. Let's just tell main to wait. So we're going to tell main, after it does line 18, we're going to tell main to delay its exit. Okay, and so all we have to do is to tell main time that sleep. So we're going to tell main to sleep. How long? Well, let's time that second. So we're going to let main sleep for a second. In essence, that simply means that the main function will be swapped out, okay, and some other function will be run. Maybe it might be hello, maybe it might be world. We don't know. So in essence, sleep basically means let's block main. Let main wait. And because main is waiting, and because you know the CPU doesn't want to be idle, it wants to do something, it goes and looks for something to do, which in our case means executing one of those other two functions. Okay, so let's give this another run. Okay, so now finally you see that they get a chance to execute. Now, if I run this again, I want you to notice something. Okay, let's run it again. Okay. You notice that it's getting world first, but you might be thinking, yeah, it's gonna always print world first. And the thing is, that's not sure. Okay, it's not a given. And I just showed it to you here, right? This time, hello comes first, then world. But in all the other instances, it was printing world, then hello. And that's what I mean by it's not determined beforehand. It's not deterministic. And that is the problem when it comes to Goroutines and concurrency in general, that we don't really know. And so going forward, we will learn about mechanisms that allow us to get a better handle on ensuring that we have a good idea what and when will be executed and when. So in other words, we want to be able to synchronize the Goroutines. Okay? All right. So that is the big picture. And again, currently we're just using time to let main sleep, which gives hello and world a chance to actually execute. But using this approach here is not the recommended way. So we'll be learning all the methods, all the mechanisms that allow us to ensure that our Goroutines get to run and that our Goroutines know how to communicate with each other. The whole point of Goroutines and concurrency is to be able to have them communicate with each other so that they can make the work go faster. All right? Okay, so that pretty much brings us to the end of this lesson. And keep in mind, because of the nature of Goroutines, you'll notice that we don't have any return values. All right, so there's no return values when it comes to Go routines. All right, I'll see you in the next one.